Well, in the next couple of videos, we're going to talk about the radiation. We're going to talk about the types of the radiation. There are 3 or 4 different types of the radiation, basically the alpha radiation, beta radiation, and gamma radiation. But before we do this, let's talk about the alpha, beta, and gamma particles. So as we've seen, the structure of the atoms previously, it has a nuclei in the middle, and there are some electrons around this nuclei. So let's look at this nuclei in more detail. So the nuclei of every atom is going to contain the protons, which are positively charged, protons, or neutrons, which are neutrally charged, which basically doesn't have a charge. In every element in a period, so if we look at the elements in the periodic table of elements, we can see that it has some number, right? So for example, if the element in the periodic table has a 12 here and 6 here, it means that the 6 is called the atomic number. It basically tells us how many protons it has inside its nuclei. So it's basically the number of protons. And this number 12 is called the atomic mass, which is basically the number of neutrons plus the number of protons inside its nuclei. So depending on the number of the protons or the number of the neutrons inside this nuclei, we're going to define those 2 numbers for every element. For example, the P, the proton, is going to be denoted as 1 and 1 since it has only 1 proton, and its atomic mass is also equal to 1. So it's going to be the proton. And can you guess what's going to be a notation for the neutron? So the neutron, how many protons it has? It obviously has 0 proton, but its mass is equal to 1 because the mass is the number of the neutrons plus the number of the protons. So this is how we're going to denote the neutron. So we call the helium, for example, with the mass 4 and with atomic number 2 as an alpha particle. Basically, this is its nuclei is going to look roughly like this. It's going to have the 2 protons and 2 neutrons. Or we are going to denote it as an alpha, 4, and 2. So this kind of particles are called the alpha particles, with the mass 4 and with the 2 protons inside its nuclei. So an electron is going to be called as a beta particle, or the positron is also a beta particle. So we are going to denote an electron as 0 and -1, or beta 0 and -1. So its charge is going to be -1, right? And its mass is so small so that we are going to just denote this as 0. So this is going to be a beta negative particle. And there exists a beta positive +1 and 0 particle. So beta plus particle, which is in our case is going to be positron. So the positron was the mass 0 and was the charge +1, or was the atomic number +1, is going to be called as a beta plus particle. And there is another, the last type of the particle, which is going to be gamma particle, which is going to have no mass and no charge, which is basically the gamma photon. So this we are going to call as a gamma particle. So now we are going to differentiate four different types of the particles. Basically, the alpha particles, which are going to have two protons and two neutrons. So the beta particles, like basically the electrons or positrons, or the gamma particles, which are going to be the gamma photons without mass and without protons.